Hello, Assalamu alaikum. This is the video presentation for assignment 2 Robokar. We are from CodeCommandos. Here I am MD Munir Islam Mullah and my team members MD Abu Salam Naim, Mohammed Shafayat Hussain and Maidul Hassan Masoom. So let's get started. So the whole of the presentation will be discussion about the introduction of these projects, assignment, objectives, concurrent programming and the concurrent design for the Robokar implementation of the Robokar. And finally, we'll do the performance testing. So as the fields of the robotics has made significant advancements in recent years, so with the mobile robot playing a vital role in various industries. Developing a real-time and concurrent software for mobile robots such as the Robokar is crucial in achieving their desired performance and responsiveness. This short introduction sets the stage for understanding the importance of concurrent software development and investigating the relationship between the timing requirements and the system's reactivity or responsiveness. The objectives of this assignment is to develop a real-time and a concurrent software for mobile robot and embedded system to control and navigate the various tasks in concurrent and parallel manner, and to investigate the relationship between the selection of the timing requirement and the reactivity or responsiveness of this Robokar. So what is concurrent programming? Concurrent programming is a particularly relevant in scenarios where tasks needed to be executed independently or concurrently to achieve the desired functionalities and responsiveness. In concurrent programming, the tasks or processes are executed concurrently and can interact with each other through the shared resources or by passing messages. So concurrency can be achieved through the various techniques such as multi-threading, multiprocessing, or distributed computing. So we'll be here implemented in concurrent programming in our assignment too. So in the next stage, our friend Maidul Hassan Masum will explain the concurrency design.
Assalamu alaikum. I am Maidul Hassan Masoom, and now I would like to explain our activity diagram. So once we turn on the robot and it gives the honk, after that when we press the start button, it start working, it start moving following the line, and after that it try to maintain the concurrency task. I mean 3 tasks at the same time, checking the collision. Also the motor is being controlled, the speed and everything, and the navigation also, when to go left or right following the line. And this is how we complete the race and we stop there. Now let's look on our sequence diagram. So once we turn on the robot and it gives the honk and wait for the start pressing button. Once we press that, it go to our main function, and once the application is started, the system is started, it go through the task create function. Now in this function we can see a black bold and black sign. This is referred to the collision, which usually shows the concurrency work. We use it for showing the concurrency work. As for our system, the 3 tasks, check collision, control motor, and the navigation are being used as concurrency task. I mean at the same time they are working. So and they goes to the task start function and it works to our line following route. And this is how our system is working. So that's all from me. Pass it to our next person. Thank you.
Real-time system works based on the prioritization. So here we have 4 prioritization. First is to start the task, second one is to collision detection, third is the control motor, and the fourth is the navigation, which is a low priority task. So for the task priority execution, we have the first one, which is task start. So task start is a function which makes the task start function to be ready upon the press, then execute it. In the task start function, we have multiple elements which we need to be focused on. First of all is the OSTIC init. Actually, this one helps to enable the RTS time metric, so it helps monitor the timing system of the real-time system. These other 3 are the other concurrent tasks, which are collision, check a collision, control motor, and navigation. Here we can see that there are stack allocation from here. So those are the stack allocated for the start task, check collision, control motor, and navigation. The last one we need to be focused on is the time delay function. So whenever a compiler runs, it should have a 5 millisecond delay for every start task execution. Check collision is one of the concurrent tasks in our system where the robot sends the object based on the proximity sensor, and the proximity sensor updates the obstacle obstacle variable every time. This is done based on a period which is 1 second. The another function that we have is the control motor. Control motor is also a concurrent task, and it actually gives the speed for the motor both sides. Every time it delays 5 milliseconds. It uses motor speed function to control the motor speed. Navigation is the low priority task which actually helps the robot to move around and follow the line follower. The task begins with the initializing values and settings required for the navigation. It enters an infinite loop to continuously perform navigation operation. Within the loop, the function reads the line, the sensor values, and calculate the error based on the desired center value. Depending on the error value and a specific condition, the task adjusts the motor speed to correct the motor's position. The task also handles specific scenarios such as the obstacle and the light sensor detection by modifying the motor speed accordingly. Additionally, to keep the track of a specific checkpoint reaches during the navigation and adjust the control parameters based on the checkpoint counts. The task utilizes PID control by accumulating error over time and calculating the derivative term to find the motor tune, and it periodically delays every 5 milliseconds and then allocate to the next task.
Now I will show our performance testing videos. So we have completed our first checkpoint within 6 seconds. Then the second point took a little bit of time and it has completed within 13 seconds. Then our third checkpoint has been completed within 11 seconds. Then we try again for the light sensor, and for the fourth checkpoint it took 11 seconds, and for the final checkpoint, which is checkpoint 5, I have completed it within 7 seconds, so total 48 seconds. So thank you for watching.